Hi, today I would like to present my final year project, Worldwide Online Accommodation Reservation System with Multifunction. And my supervisor is Professor Wong Wing Sheng. What I'm going to present to you today is my brand new product, the NFC Power Lock, a magic that turns your mobile phone into a power source. The main technology that are being used in this project is NFC, which stands for Near Field Communication. It's a feature in many portable devices today, just like your Wi-Fi or Bluetooth. Please let me shortly explain the working principle of NFC. Technically saying, there are sets of standards for portable device which allows them to establish peer-to-peer radio communication, passing data from one device to another by putting them very close together. Behind the scene, it uses electromagnetic induction in order to transmit information over a short space. A radar in the NFC device emits a small electric current, which creates a magnetic field that in turn bridges the physical space between the two devices. That field is received by a similar coil in the client device, where it is turned back into electric impulse to communicate data. For the next part, I will briefly explain the architecture of my project. In the first step, user book a room in the booking system with their identity. The booking system will pass the booking information to the hotel server. Followed by step 2, the hotel server will write the booking information and the specific virtual key of the user to the database of the hotel. Afterward, the hotel server will pass the result and that virtual key back to the user. Followed by step 3, the user will head to their booked room directly without any check-in process and present their mobile phone in front of the NFC door lock, which will pass the specific virtual key and the booking information of the user to the floor server. Simultaneously, the floor server will request the back-end server to verify the identity of the user. Followed by step 4, the back-end server will return the result to the floor server after doing verification, and based on the result, the floor server will pass the decision of open the door or not to the door lock. Below is a basic hierarchy of the network deployment of the hotel. Each floor will have one server to handle all the NFC traffic of that floor. They will all route to the back-end server, which will process the verification of identity of the user through fetching and matching the booking information from the database. The benefit of this hierarchy is, first, the security, as it physically separates the back-end server and the floor server, which creates a DM zone, demilitarized zone, just like adding an additional firewall to protect the back-end server and the database from malicious attack. The second benefit is scalability, as each floor has one server to handle the requests on that floor instead of sending the requests of the whole building to one server. For example, in the peak travel season, if all floors connect to the same floor server, as a result, the server will experience an extremely high workload, which will cause the server to break down or disconnect simultaneously, as it cannot support that huge amount of requests at the same time. In the next part, I would like to describe more about Android development. As you know, we bypass the booking system and assume the user successfully booked a room. Then, a virtual key will be distributed, which held by the hotel and used by the user. This process is referring to our step 1 and 2. The project has a client-side programming, which is Android client, our mobile application, since our project bypassed the booking system, for example, like Agoda. However, to simulate this process to get the booking confirmation from the hotel, I have implemented this process in my Android client application either. Regardless of the former, the main function of my Android client is to make use of the NFC feature to enable the right user. In case to achieve what I mentioned above, we have to understand the Android NFC behavior first. The Android NFC have 3 modes. The first mode is reader-writer mode, which enable NFC device behave as a reader for NFC tag. Once detected, it can either read data from or write data to the detected tag. The second mode is peer-to-peer mode, which enable 2 NFC devices to exchange information between each other, for example, the Android Bean. The third mode is card emulation mode, which enable an NFC device behave as a contactless card. I would like to highlight this mode 3, as it is the one that being used in my final year project. In this card emulation mode, we can use our mobile phone in place of access card, for example, our hotel room card. I would like to go inside to describe more about my Android mobile NFC functioning. Regardless the previous mentioned three modes, the basic NFC behavior will act like the left figure. Above is the user's Android mobile phone, and below is an NFC card reader, which being installed in the hotel room lock. When they put very close together, the electromagnetic induction between them will form a channel, which enable them to initiate the communication with data transfer. In this topology, all data and traffic will be only handled by the secure element, which always responds and returns a single output to the NFC reader, as a result affecting the information received by the NFC reader. Because of this design topology, Google wrote a solution called HCE. Well, at this point, please let me introduce a new term called HCE, which means whole space card emulation. You can refer to the third mode of Android NFC previously mentioned. While the application has been programmed by the HCE, will route the communication directly to the host CPU instead of the secure element. As a result, the NFC reader can read the accurate content from the host CPU. Now you understand why the HCE of our mobile phone can appear to the door lock terminal as a contactless card. At this time, the door lock terminal can't distinguish between your card and your phone. That's why HCE is so significant in Android client part of my project. I would like to point out what components have been used in the server side in my project. I've been used Unity to simulate the door open scenario and the hotel room. The door lock in Unity has been connected to the floor server, which is simulated by this computer and programmed by C#. The floor server will transfer the door open request with the NFC collected data to the backend server, which use PHP and MySQL to implement. The floor server has a C# program for initializing and sending the HTTP request to the backend server. I would like to highlight these two code lines. The first line is creating the HTTP request, which passes to the backend server through streaming and waiting for the HTTP response. The second code line implies that once the server responds this request, the floor server will transfer the local unknown signal to the backend server. At the backend server, I use PHP and a server script and MySQL to handle the database. The backend server will record all the successfully booking items into the database, and also, in addition, it will handle all the NFC content from the floor server and verifying the identification of the user. After that, it will transfer the result to the floor server. In the next part, I would like to physically demo the project for you.